Okay, last one, practice 5, number 6. It says, Li Pingfar, the esteemed Chinese ski jumper, has a mass of 59 kilograms. While practicing his jumps, he lands on a large trampoline. Leaving the jump, position A, he is moving with a speed of 23 meters per second at a height of 44 meters above the ground. The trampoline is located at a height of 10 meters above the ground, position B, and he stretches it 2 meters as he comes to a stop at position C. What is the spring constant of the trampoline, and assume no ED? Okay, wow, this is a biggie. Okay, all right, so we need a picture here. Wish I had some more space. Okay, so let's think about what's happening here. Okay, so we have the ground, okay, and then we have some kind of a ski jump, right? And then he's going to land in this trampoline, okay? So let's make the trampoline like a little bit higher, all right? Okay, so the trampoline itself is 10 meters off the ground, okay? But then what happens is he's going to jump into it, okay? 2 meters, he's going to compress it, if that makes sense, okay? All right. Leaving the jump at position A, okay? So that's actually going to be like down here. Leaving the jump at position A, he's moving with a speed of 23 meters per second at a height of 44 meters, okay? So he has EG and EK, no springs, and no ED ever in position A, okay? All right, so let's go ahead and see if we can find that. So EG equals MGH. Okay, his mass is 59 kilograms times 10 newtons per kilogram, and it says that he's 44 meters off the ground. Okay, all right, so 59 times 10 times 44. Wow, that's a lot. 25,960 joules. Okay, let me just make sure I did that right. 59 times 10 times 44. Yeah, okay. He's also moving at that point. Okay, so I've got 1/2 times his mass of 59 kilograms times his speed, which was 23 meters per second. Don't forget to square it. Okay, again, punch this in your own calculator and make sure you get this number. Okay, don't just look at mine. Okay, so that's 15, I'm going to round it, okay? 15,606 joules, okay? All right, so I have 15,606 joules of EK and 25,960 of EG gives me a total of 41,566 joules because I got nothing. All right, so it looks like about, let's see, 25, a little over like 60-something percent. EG, a little less EK. Okay, a little more than half EG, a little less than half EK, 41566. Okay, 41566, 41566. All right. Okay, there, position B. Okay, he gets to the trampoline that's a height of 10 meters above the ground. That's position B. That's all we've got. Okay, so at 10 meters above the ground, all right, he has EG. He's still moving because he's just moving into the trampoline. Okay, the trampoline did not stretch yet, and it says ignore ED. Okay, all right, so let's see what we can get here. So this is going to be 59 times 10, okay, times 10 meters above the ground. Okay, so his EG is going to be 59 times 10 times 10, 5,900. Okay. Right? So if I have a total of 41,566 minus 5,900, I know I'm going to be left with 35,666 joules for the EK. So most of my pie is going to be EK. So I'm going to have a little EG and then a whole lot of EK. Okay? Okay, because the trampoline is not stretched and there's no ED. Okay, now, we should have probably asked for how fast he's going here. Okay, so I'm going to go ahead and find that because that would be something I'm going to probably change in the future to ask. Okay, so 35,666 equals 1/2 times his mass. Whoops, what keeps happening here? Times V squared. Okay, so I've got 35,666, okay, divided by 59 times 2 is going to be 1209. Okay, 0.5 times 59, 29.5. Okay, and so then my velocity is going to be the square root of that, which will be 34.8 meters per second. Okay, they didn't ask for that, but I should have. I'm going to change that for the future. Okay, 34.8. So if you're watching this in a future year, it already says it. Okay, all right, now position C. Okay, let me pause it, and let me just write down the total so I don't forget this time. Okay, and let me pause it so I can get the other thing up. Okay, so now let's do position C. Okay, the total energy is still 41,566. Okay, and it says that he stretches it 2 meters as he comes to a stop. Okay, so I think you can see over here, right? So if here's the ground, right, and here's the trampoline, this is 10 meters above the ground. He's going to stretch it 2 meters. Okay, so I know there's going to be EK because there's something stretchy that's stretched or compressed. And he's still above the ground, okay, because he's still here. He's still 8 meters above the ground, okay, but he's not moving because he's come to a stop and we're ignoring the ED. All right, so my EG is going to be MGH. He's 59 kilograms times 10 times 8 meters above the ground, okay, because he's still 8 meters above the ground even after he stretches the trampoline. So 59 times 10 times 8, he's going to have 4720 joules of EG, all right? He's not moving, we're ignoring the ED, so then I know my total, 41,566 minus 4720 that are taken up by the EG, so I'm going to have 36,846 joules of EE, okay? All right, and it's telling me that he's going to stretch it 2 meters, so that's going to be squared. So 1/2 of 4, if I divide by 2, I'm going to get rid of all this stuff, okay, because 1/2 of 4 is 2, divided by 2, so K is going to be this divided by 2, which is an incredibly huge spring constant, newtons per meter. Seems wrong, but I'm guessing it's okay. All right, 18,423 newtons per meter. That's an incredibly strong trampoline, but I guess maybe it would have to be to stop a guy, okay? So the EG is a small amount, maybe only like 10%, okay? And then the rest, a lot of it is EE, okay? Right, maybe only 10% EG and the rest EE. Okay, good. All right, that is it.